Today, I plan on showing how I added directional lighting to my Bachmann BIG Hauler locomotive. In a previous video, I showed how I replaced the chassis on my BIG Hauler locomotive. And in the process, I rediscovered that years ago, I had added directional lighting using 1.5 volt grain of wheat bulbs and a simple array of diodes. I mentioned in that video that if anybody was interested in how I had done that, I would follow up with another video. So I actually received a request, so I'm putting this video together to fill that need. If you find this video useful, please give me a like and consider subscribing to my channel. So the main component that you would need for this diode array is the diodes themselves. Now a good choice is the ubiquitous 1N4001, which used to be readily available at like Radio Shack and so on, but nowadays one has to turn to the internet. So I think an internet search would show a lot of different sites, but I just picked one that I'm familiar with, which is SparkFun. And as you can see here, they're relatively inexpensive. You'll need 6 for this project, but it wouldn't hurt to get some spares. The other key component is a grain of wheat lamp, and I did specifically 1.5 volt. So the keys on determining what to purchase for these grain of wheat lamps is the size, the voltage, and the fact that it has leads, and of course we want them to be clear. So the Amazon choice actually looks like a pretty good candidate. You can see here they're clear. 3 millimeters is probably a little on the large side, but they would work. They're 1.5 volt, and they have leads pre-attached. Now they come in a bundle of 50, which is kind of amazing. And for $13, and it's kind of a shame if you only need a couple of them. But if you have a layout and so on, perhaps they can be used for other things. And then finally, an optional item, which I happen to use, not this particular device, but to kind of help smooth out the potential flicker due to the intermittent nature of the contacts of the locomotive as it makes its way around the track. Well, you can add a capacitor to each of the 2 lamps to just kind of reduce that intermittent flicker that you may get. So the starting point for all of this is to recognize that I'm just going to do a quick sketch, kind of as a schematic sketch, that normally the way we have this connected is we just have the motor, which is represented by a circle with these 2 little squares around it to represent brushes. That's our motor. And I'm just going to use little circles to indicate where it's connected to track power. So typically this is what we have connected in our locomotives. So we can either be plus and minus, or they get reversed and we have minus and plus to drive the motor in opposite directions. Now for this particular diode array, what we need to do is we have to break the series connection to the motor, because it's a current based setup. So I'll have to demonstrate how I did that on the locomotive, but let's just say for the sake of argument that this right here is my diode array. And it's just going to work on treat it as a little black box, and then it gets connected to the motor in series. So we have to disconnect our motor from the pickups inside the locomotive in order to attach this diode array. So what does the diode array consist of? So it's actually, in some respects, it's a pretty simple circuit. So what we have here is we just come in from we break one connection to the pickups. And what we're going to do is we're going to have 2 separate branches, one for each direction. So the first thing that we do is we add a diode, which is represented like so, and it's labeled, they are labeled D, capital D. So the line represents the cathode, or the negative side of the diode, and the open end of the triangle is the anode. So when voltage is applied across this diode such that it's positive on the anode side and negative on the cathode side, current will flow through the diode. But when it's reversed, it blocks flow of current. So it works a lot like a check valve. So we do the opposite down here. We connect another diode in the opposite direction. So again, it's just a capital D. So these are our steering diodes. These are the diodes that actually will select the headlight from the tender light. So the part that's a little bit confusing about when you first see a drawing of this nature is, I'm going to extend it out a little bit just to make it a little bit more clear, is what we're actually going to do is we're going to actually include two more of the exact same types of diodes, and we're going to put those in series in the same direction. I'm going to show them kind of close together, and I'm going to do the same thing down here, but I'm going to put them in the opposite direction. So these two diodes are our steering diodes, and they determine which way the current's going to flow depending upon which way we actually command our locomotive to go. And then on the back side here, we'll tie these together and we'll connect these to our motor. And then back around to the other pickup, which we can leave undisturbed. So what's happening is these two diodes determine which direction the current's going to go. So in one direction, we're going to have current flowing through these diodes through the motor, and then when we reverse the direction, the current will go through the motor and through these diodes and back around to the track. These two diodes, we're taking advantage of the fact that there is a voltage drop when current is flowing through them in the forward direction. And for a 1N 4001, it's approximately 0.8 volts. So we get about 1.6 volts total across these two, across both diodes. So what we're actually going to do then is we are going to bring out from here and here a connection to our lamps. So I'll just show that typical incandescent lamps, a little squiggly line. So this is our 1.5 volt green of wheat lamp. So you can see that the voltage is a little bit on the high side, but the 1.5 volts kind of a nominal voltage. And we'll do the same down here. I should have left some more room for my drawing. I'll just show it like so. And there's our other bulb. So again, this is approximately 1.6 volts, dropped across here. So the other thing that we can do is we can optionally add a capacitor, which is showed as two parallel plates. Now what I showed earlier, these are electrolytic capacitors, which means they have a polarity associated with them. So when they're connected, the side that's labeled plus needs to be connected over here to this anode, or the side on the diode that does not have the line on it. Or conversely, if the capacitor is marked with a negative terminal, that gets connected to the cathode of these two diodes. It's sort of, for the moment, ignoring the steering diodes on the left. And of course, the same can be done. The same can be done on the other side. So these are plus and minus. So these are caps again. So I hope this kind of makes some level of sense. So again, just to recap, we are getting a voltage drop across these steering diodes, which again is on the order of 0.8 volts, and 0.8 volts as well down here. And just I don't know if it's obvious, but you need to have these diodes here, because if these were shorted out, if you just shorted out these two diodes, then these two guys themselves would be in parallel with each other, and they'd be connected to each other, and both lights would light up the same way. So you need these two diodes to separate these pairs. But then you need these two diodes just to give you that voltage drop across them for the grain of wheat lamps. So I hope that makes sense. And if it doesn't, please feel free to ask me down in the comments below, and I'll try to clear this up. So the trick to this, really the trick to this whole method, is that one has to find how the motor is connected to the pickups inside the locomotive, and break that connection, which is what I hope to show next. Diodes come in different sort of varieties, but to kind of tie this back together, if we draw schematically our diode like so again. Okay, that's our diode, and I'll just put a capital D here. So here's one example of a diode that it's a black diode, and it has a little blue stripe on one end that shows the cathode. So the end with the stripe on it's called the cathode, and the other end is called the anode. And if this end is positive and the cathode end is negative, then current will flow through the diode. But if it's reversed, it gets blocked. So here's another example. This time it's a littler diode that happens to be blue with a black stripe. And then, as you'll see in a moment, when I built my directional control diode array in my locomotive, I used these. They're actually glass-bodied diodes, which are reasonably clear, but they have a black stripe at the same. I'll flip it around so you can see it the same direction. It has a black stripe on the side that's meant to be the cathode, as you can see here. So I got my locomotive pretty severely torn apart. And the first thing I just wanted to show is Bachmann, at least on the Series 5 anniversary chassis, they provided these two little connections into the pickups. Got these little sockets so you can unplug the pickup piece, and you can set that aside. So that's pretty handy. So a couple things that I needed to kind of point out here is there's these two bosses with screws in them that they use to connect the motor. The motor leads to everything else. So this is sort of the main power distribution point, and you'll see in a second why that's important. So I'm going to flip this part of it over, and I'll show what I did. Everything's kind of hanging loose now. So it looks like a lot of wires, but if you just kind of follow it through, you'll see it's not so bad. So first of all, my unit has a smoke unit. So this is the switch for the smoke unit, which we can kind of ignore for the time being. With sort of one thing I just wanted to point out. When I got my locomotive back in 1992, it already had it had this grain of wheat lamp in it that was 12 volts, and it was just connected directly across the incoming part of the smoke unit. So it's a 12 volt bulb, because track power is 0 to 12 volts, both plus and minus. So what I actually had done is I had just disconnected one side of the bulb, but then I just went ahead and left the bulb in there, I guess with the thought that if I ever wanted to return the locomotive to its original state, I could just hook that bulb back up. So that's why that's hanging there. The anniversary chassis came with a reversing switch, which kind of adds a certain level of complication, I guess, to it. And I can explain how a reversing switch works too. It's really pretty simple, but that's really not part of this video. But essentially what's happening here is that you see it's kind of cross-coupled with these two wires. Let's see if I don't know how well I'm focused pretty well. So what I did is I broke the connection that came in on one side. So if you follow this wire back, this is the black wire that goes back all the way back to the motor. So what I had done is I had disconnected the red wire that goes all the way back to the motor, which is here. Okay, so this red wire here used to go to the reversing switch where my striped wire goes. So I unsoldered that wire, and this is where my diode array goes. Okay, so this is what we can talk. If you just kind of refer back to my drawing, you can kind of see what we have here. So you can think of it as this is now the part that goes to the motor, and the striped wire, for all practical purposes, is my track power. So this is my connection that goes between my two steering diodes. I want to make sure I'm doing this. Yeah, that's correct. It's a little hard to see, I know. So this diode and this diode are my two steering diodes. So you can, the one's facing the cathode's on the right hand side, and you can see that there are these three in series. And then the ones below me here, the stripe is on the left hand side. So this one and this one are my steering diodes, and then these two as a pair are my my tender diodes, and these two here actually go to the headlamp and the locomotive. So here's the grain of wheat bulb that I had purchased some time ago, and you can see these leads are very, very fine. And the bulb is not exactly the same size. It's a little bit shorter, but it's approximately the same diameter. In fact, if I put a scale up against it here, you can see here that it's it's sort of in the 2 to 3 millimeter range. So those bulbs that I showed on Amazon would actually work fine. So in my case, I use these. These are actually signal diodes that I had laying around, which actually are quite a bit lower current handling capability than the 1N4000 ones. So I had some 100 microfarad capacitors laying around, and you can see here, as I mentioned before, they're marked with a plus. So the plus goes to the non-striped side of these two diodes, and then on the opposite side, it's exactly the other way around. So the other thing that I did is I pulled these two wires, the two wires that go back to the connector for the tender connector to run the tender light. These two wires will also connect directly to those motor boss connections. So I had just removed those, and as you can see, I kept the ring terminals intact on both the negative terminal and on the positive terminal, and I just soldered directly to the crimped part. Again, the thought being is that if I decide in the future to upgrade or change, I guess, my locomotive to LED lighting, I can restore the original wiring without having to hunt down some new ring terminals. So this is it's kind of a mess. It looks like a mess, and I'm sure the reason I did this was I was kind of in a bit of a hurry. It was probably right before Christmas, and I was trying to impress the kids or something, give them something a little more fun to play with on the directional lighting. So you can see, maybe it's not real obvious, but I just took two diodes, for example, and I put them end to end, and I just twisted them, kind of like what you would do a bread tie. I soldered them, and then I just clipped it. So I just put three of them in series like so, and then I twisted the ends again and added solder. But what's nice is it's not pretty, but it's a self-supporting structure. I mean, the correct way to do this would be to attach everything to for example, a piece of perf board, or lay out a printed circuit board and so on and so forth. But this has the advantage of just being very simple, and once it's tucked up inside of a plastic boiler on a locomotive large like these Bachmann G-scale locomotives, it works just fine. So yeah, I hope at this point I've answered kind of all the questions about how this is done. Again, just to summarize, you need to find out where the motor is getting its power from ultimately, break that connection, build up this little array and insert it, and then determine which pair of diodes goes to the cab when it's going forward versus when it's going reversed. And what I actually just did is I just took the connections from the power supply that's supplied with the Bachmann set, and I just connected it directly to the pickups, and I actually ran the locomotive to watch which way the wheels went before everything was completely soldered up, or I tack soldered it, and I think oddly enough I got it right the first time. So rather than thinking about it too hard, it was just a trial and error thing. And then once I got the headlight connected correctly, like I said, I just took these connections going off to the connector on the rear of the locomotive, and I just connected them to the other set of diodes to head off to the tender. So anyway, I think that pretty much concludes the process for how you add directional lighting to a locomotive using old school incandescent 1.5 volt green or wheat bulbs and 6 diodes. Now, as I mentioned before, the capacitors are totally optional. It's something that I thought would be a good idea at the time. Strictly speaking, you could completely leave those off, and I think you'd be happy with the results. So in the future, what I may consider doing is actually converting this over to LED lighting. And part of the reason that I didn't at the time was I was concentrating on doing the chassis replacement, and it's not clear. This is the headlight assembly. I guess what wasn't clear is whether I'd be able to find LEDs that I'd be able to get inside my housing, without drilling bigger holes or whatever. And plus, LEDs sometimes can be kind of harsh. The lighting's kind of harsh, and maybe overly bright for my liking. Again, if I'll make another offer. What's the difference in LED lighting versus 1.5 volt grain of wheat lighting, and how does that get installed in a locomotive? I can probably try to answer that question, although I have no immediate plans to actually do that with my locomotive. So I hope you found this useful. Please let me know in the comments below if you have any additional questions. Give me a thumbs up if you like this video, and subscribe if you'd like to see me in the next video. Okay, time to test. Hoot, hoot, shh. Ding, 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 ding. Psh. Hoot, hoot, hoot. Shh. Hoot, hoot. Hoot, hoot, hoot. Psh. Hoot. Hoot, hoot, hoot. Hoot, hoot.